Hello, Code Monkeys. Today we're going to look at pointers. I know I said we were going to do structures in the last video, but I wanted to cover pointers first because structures rely on pointers pretty fundamentally once you get past the very basics. So let's dive right into it. If we run our ls, you'll notice that we actually don't have a pointers file, so let's make it with the touch command. And open it up with Nano. We're going to be using printf, so we're going to #include standardIO.h. And as a surprise tool that will help us later, we're going to include standardlib.h. Main always returns an int. Ooh. And it takes an integer called argc and a character double pointer, hey, we're finally getting around to it, called argv. And don't forget your actual return statement. Alright, a pointer is a type of integer that refers to a memory address, and therefore, on its own, it doesn't do a lot. What it does do is it refers to other things and allows you to access them more easily in cases where it would be prohibitive to go via the normal method. So let us declare a pointer. It'll be an integer pointer that is a pointer to an integer, and we use this little star symbol here to indicate that it's going to be a pointer, and we will call it leet, because that's a cool word from my childhood. And we need a regular integer for it to point to. One moment. Use this _p to indicate that it's a pointer. And now that I'm thinking of it, we should probably declare our regular integer first. We will set it equal to the address of our regular integer using, I believe this is called the reference operator. And then we can do all sorts of cool stuff with it, like we can assign leet a value through the pointer using the dereference operator, which is actually also this little star here. While I'm thinking of it, a lot of people and a lot of books will show you this syntax. I don't like it. I think this is more intuitive because it indicates that you're declaring an integer pointer as like a data type. It makes more sense to me. If you do it like this, you will be in good company. All the books show it to you that way, but I'm going to do it this way because I'm a rebel gamer. That's how I do things. Let's assign our variable a value. So the value associated with the pointer will be, I wonder who saw that number coming. And we can also reference it with printf. The leet number is is. Gotta have an exclamation point. And, oopsie, p. There we go. And here's hoping this compiles without errors. We can chop out some of that white space there. And compile it with the same line as always, force ANSI compliance. Define your output file. I'm sorry, your output file and your input file. Haha. And there you go. We'll head back in and let's get to something a little more advanced. Another thing you can do with pointers is they work very well with what they call dynamic memory allocation. There are a couple ways to do this. I'm a big fan of the malloc function. And the malloc function will return a pointer to an area in memory the size of whatever you put in here. The best way to do it is to use the size of, I think it's a built-in, I don't think it's a function. But it works just like any operator, but has the syntax of a function. So we'll go ahead and put an integer in there. You can give it a defined data structure, or you can just give it a type. In this case, we're going to give it a type, but we could have just as well put in there and gotten another one. So let's clear this out. Malloc's going to return a pointer, so we're going to need a pointer, and it'll be an integer, and that'll be an integer, and we will still call it leet_p, same as before. Ooh, extra digit there. Malloc is a function that is included in standard library, so make sure you include that if you're going to use it. Compile it with our same GCC line. Oh, what did we get here? Invalid operands to binary pointer. Aha. Well, it's always good to get some practice debugging, so that's where we are. I believe it is mad about this. Invalid operands to binary pointer have void star and int star. So. Okay. Malloc is returning a void pointer, and it does not like that very much. I think we can fix this. Always good to get practice debugging. Things like this will happen quite a bit. So I think it'll be okay with us leaving it like that. So this is called casting. It's when you sort of turn one data type into another. There's a lot that goes on with it, but pointers are actually quite easy because pointers are all the same. It's just what they point to that's different. So I believe we can just call this an int star. And that might work for us. Alright, what do we got here? Operands binary have void int. What if we tried that? Alright. Dereferencing void pointer. There we go. It doesn't like that. Alright. This is progress, believe it or not. We'll watch this. We're going to do the same thing again. That should do the trick. Good golly. Dereferencing void pointer. Well, I didn't expect to run into this today. If we go ahead and comment this out, can we get this to at least compile without error? No. I know it's a void pointer. Why are you making this difficult for me? Not over Spider-Man. Oh, did I forget? Is that the whole issue here? Did I just bungle? Yup. Well, even your master tutor here makes mistakes. Programming is frustrating, and that's just something y'all gonna have to deal with. Yup, there we go. I suppose if I remade this video, I could make it look a lot more professional, but I do think it is instructive to get used to the troubleshooting process. You're going to be doing it a lot. Hey, there we go. Now what happens if we run it? There we go. We have successfully used malloc. Thanks for bearing with me through that. What else can we say about pointers? Arrays are pointers. That's an important thing. We haven't done much with arrays yet. But maybe, just maybe, that's not what I wanted to do. There we go. This is probably a good place to start. If I remember the syntax correctly, let's go ahead and comment this out. We'll use it later. And we'll make an array of 2 integers. And we'll initialize it to about 0, 1. That should work. Change this just a little bit. For now we have 2. I guess we didn't need all that junk. Kind of a wasted cast. The optimizer should have taken care of that for us, but it's always good to write tighter code if you can. And these braces here are kind of interesting because they're actually a dereference operator just like the star is. And I'm going to go ahead and say we should produce some code that demonstrates that. So how about this will refer to the first value in our array because the array is a pointer. And if we dereference it as an integer, we will get the first integer in the array. And if we dereference the second integer, the only way to do that, pardon me, that's not accurate. There's multiple ways to do that. You can use what they call pointer math, or you can use our handy array dereference operator, like so. That should function just fine. Oh, look at me. I'm forgetting semicolons all over again. And another compile. Oh, it did not like that. Maybe, just maybe, that isn't part of... ANSI C. That shouldn't have been there either. Making mistakes all over the place today. That's alright. Let's just see if that'll compile at all. Remember, it doesn't work if it doesn't compile. But if it does compile, that don't mean it works. If we go ahead and run that, we should get some gobbledygook out. It'll be kind of funny. Hey, hey, hey! There you go. Arbitrary numbers. C doesn't initialize your variables for you. You gotta do it yourself. So, let's do that. I believe you can just do this, and this will zeroize your entire array right off the bat. No, it doesn't like that either. What are you gonna do? Initialism by hand, of course. And there we go. So, as you can see, this array is a pointer just like any other, and we can access the very first value inside it with the normal pointer functionality, but we can use the special array functionality to access subsequent values, which is admittedly not something you're going to do a lot, but it is handy to know. Now, one last thing we will want to see is that you can actually initialize arrays with malloc. So if we come back up here, you see we've got size of int in here. We can do size of int times 2. Snazzy, no? And we can do just the same thing we did before. And we'll go ahead and come back down here, make sure we got these right. Haha. That's not what the variable was called, it is leetp. Make all the jokes out of that you want, folks. Go ahead and recompile, and hopefully we get the same thing. Hurrah! And I think we're going to leave it there for our basic introduction to pointers. This is a topic that very much does get deeper, but we got to leave things in some kind of bite-sized chunks. I hope you all learned something, and have a great day.